We're there. Hey there. Hi there. Ho there, everybody on the wide world of Al Gore's internet. We're here with OpenCV Live. It's Thursday morning, 9 a.m., and you know what that means. It's OpenCV Live, episode 179, if you can believe it. And we have a gangbusters episode here with our friend from IBM Research talking about some state-of-the-art large language vision models, a field that is moving incredibly fast. We were talking just before going live here today that it almost feels like a science fiction movie where the advancements come out of left field sometimes, and you're like, wait, this model just dropped that now we got to redo everything, right? It's such an interesting time to be in the field. Of course, I'm here with Dr. Satya Malik and Pangyan. Where are you joining us from today?
I'm from San Jose, California, actually. Nice to meet you, everyone.
Yeah, right on. And of course, I'm coming to you from beautiful, fragrant Soma in downtown San Francisco, California. And our stalwart host, Dr. Satya Malik, where are you joining us from, Doc?
I'm joining from Las Vegas today. So this is, a different location today. Yeah, it's very exciting, very hot here. Unlike San Diego, which is chill the whole time. This is like 93 degrees at night.
Yeah, it's the temperatures are quite spicy in Lost Wages. What brings you out there?
Well, there's a business workshop I'm attending. So that was, and then I told my family, I said, why don't we go to Vegas? I'm already there, and you can hang out with me for, a few days. And they said no. And I said, yes. So I called up two of my friends and I said, look, I'm in Vegas, right? Why don't you guys come along? They said, we'll take time off. They are here. They'll be here today.
Fantastic. I love that. You're like, yes, I'm with no kids.
Yeah. So it's going to be fun. My friends will be here.
So if wherever you're watching us out there on the internet, please let us know where you're coming from in the chat. Wherever you're watching, we're live on YouTube, LinkedIn, Twitch, and Facebook. We're also up on Zoom. Of course, I see some folks chiming in on Zoom already. We've got Rodley, that's a hell of a name, from New York City. We've got David from Italy. We've got Oscar from the UK. We've got BG Seti from Hyderabad. We've got Garima from San Ramon. We've got some folks in Massachusetts, Richmond, Virginia. The global OpenCV audience chiming in here this morning. We do love to see it. And the homie Steph OK says logged in from foggy SF, where it's 40 degrees cooler than in Las Vegas.
Wow.
It's 40 degrees cooler than in Las Vegas in Fahrenheit. It's
right.
Yeah,
awesome.
Indeed. And we've got Alan Bullock coming in from Ocean Isle Beach in North Carolina. So one of the things we can do here, if you tell us where you're coming from, maybe we'll pop up on the screen here. Good morning, Alan. Good to see you here on this beautiful Thursday. I think now is a good time to get started. Doc, you want to do your intro?
Yeah. Well, welcome, everybody. Welcome to OpenCV Live from Las Vegas this time. And I'm very excited to invite Pengyong Lee, who is a researcher at IBM Research. And, as all these top companies have been working on vision language models, so has IBM. And, this is such an exciting field because it's growing by leaps and bounds. Every week there is a new model and it improves on the previous model. So I'm very excited to talk about Granite Vision, which is the vision language model IBM has released. And not only that, they have released it under the Apache 2 license, which is great. We love that. And we'll learn about what are the different things that this language model, vision language model, is capable of, and we'll know the details of various aspects of the model as well. So with that, let's get started. But as always, with me is Phil Nelson, who is the creator of this show and also the director of content and creative at OpenCV. He produces the show, and if anything goes wrong, it is his fault. Hi, Phil.
Yes, good morning out there, everybody. It's me. It's PHILLIP. I am your co-host with the co-most, the second banana who's second to none. I'm also your plus one and only, and I'm here to remind you of a few things we do on every single episode of this here program, the first of which is a special giveaway to you out there in the audience. Later on in the episode, in about 40 minutes from now, I will be asking a trivia question based on the presentation from our illustrious guest, and the very first person to answer that trivia question correctly will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. We're also taking questions from you in the audience, so please post those questions wherever you're watching, whether you're on Zoom, YouTube, Twitch, Facebook, LinkedIn Live, or even if you're just watching later on in the recording later, or you're listening to the podcast version of this show, which for some reason does exist. It's on Apple Podcasts and Spotify. You can find it by searching for OpenCV Live if you want to listen to the very visual program that you're probably watching right now. But we love your questions. Even if you're watching later, send those questions to newsletter@opencv.org, and we will do our best to answer them. I think with that, we can go ahead and get started with the presentation from our guest. Go ahead and say hi and tell the people who you are.
Hi, everyone. Thank you for joining today's talk. My name is Pengyuan Li, a research scientist from IBM Research and a co-contributor of the Granite vision models. Today, actually, I'm very excited to walk you through how we develop the Granite vision model, which is a lightweight and efficient large vision language model designed especially for enterprise AI applications. And before I dive in, I really want to take a moment to thank you, Phil and Satya, for organizing this wonderful series and for the opportunity to share our work. And of course, thank you to all of you attending live. I'm really looking forward to the discussion.
Thanks so much for joining us. We're really looking forward to it. And looks like the audience is too. Just a quick check-in. We've got about 50 folks watching between YouTube and Twitch, and we've got about 75 over on Zoom. So it's a good morning so far.
Amazing. Yeah. Let's begin with a bit of context about IBM's broader AI efforts. At IBM Research, we have been building a full suite of foundation models tailored for enterprise AI, including large language model, vision model, speech model, time series model, and safety forecast models like Granite Guardian. What you see here is a Granite model lab, and today I will focus especially on the Granite vision models, which are designed for tasks like document image understanding. One thing we are especially proud of is that all of these models are open source, released under the Apache 2 license, and publicly available on Hugging Face. IBM is deeply committed to building open, trustworthy AI for the enterprise. And yes, even the name, the model name, you can tell, Granite, because it's solid, dependable, and hopefully not prone to hallucination, unlike some LLMs. Yep.
Yeah.
So
who shall remain nameless.
Yeah. So what is a large vision language model, right? As we know, a large language model, or LLMs, work purely with text. They can read, generate, and reason over language input. But the world isn't just made of text, especially in the enterprise settings, where you often work with tables, charts, scanned documents, and images. That's where vision language model, or VLMs, come in. A VLM can take both images and text as input. For example, it can answer a question about a chart, extract structured data from scanned table, or summarize the content of a picture. Oops. Can you still see my screen?
Yeah, but we can see, yeah.
There we go. Yep.
Cool.
Well,
Yeah.
I'm going to go ahead and move your video to the top right there because one moment here. I'm going to fix the, there we go. Okay. So now folks were asking to scan the QR code. So go ahead and continue. Thanks.
Yeah. Just for the large vision language model, right? Imagine you have a model that can read your receipt better than you do. Now let me show you a short demo and see what the Granite vision can do.
Mm-hmm. The sound is not coming through. I don't know whether there's sound in there.
No worries, there's no sound there. Yeah.
So we can just kibitz a bit while this is going on. It's all good. I'm gonna swap the sources here again real quick. There we go.
Yeah. What you are saying in the demo is Granite Vision actually doing exactly that, combining the language understanding with visual context. You can upload any image like a chart, table, form, or even a complex document image, and ask any questions about it. The model can interpret the image and respond using both visual understanding and language reasoning. Yeah, it's quite amazing. Yeah.
Amazing, yeah. And this is out of the box, right? A user who is using this model, they don't have to do any fine tuning. Any document that you can think of, it's able to do a very good job of interpreting the document, and it's a visual question answer
Yes.
model as well. Okay.
Yes. Okay, so now we have seen what a vision language model can do. Let's talk about what sets Granite Vision apart. Most existing VRMs are like trained primarily on general image, like photos maybe collected from internet, but that's very different from what the enterprise actually work with. In enterprise settings, the data is more structured and more complex. Things like in
Can I interrupt to have one question before, because a lot of people might already be thinking, and my job here is to represent the users in what they
Absolutely.
could be thinking. So one question I have out of the right out of at the beginning is, uh, you mentioned that it specializes in document analysis. Is it
Mhm.
that it is good at document analysis? It still does all the other stuff, right? But
Yes,
okay, so that's the case, right? It's not like, oh, you can only do document analysis with it. It is very good at document analysis, but it is still
exactly.
good at other tasks also. But the thing that really stands out is the document analysis part of it.
Exactly. Because in our settings, we want to really focus on enterprise AI.
Yeah,
Basically, we're trying to say the model work both on document image, but also work on the general image, general QA. It still work. It's just like we are the state of the art for the document image understanding model, actually.
got it. Got it. Okay.
Yeah. Yeah, so in the enterprise settings, actually, the data is like more structured and more complex. Things like invoice, receipts, like charts you can see here, even some product menus, contracts. This require actually much more than just image captioning. You need precise understanding, information extraction, and layout awareness. That's exactly what we have focused on. Granite's vision is especially built to handle these enterprise use cases, and it's designed to be compact, efficient, and deployment friendly without sacrificing the performance. And if I go deeper into the model, I want to take a moment to acknowledge the team behind this effort. Granite Vision is a result of global collaboration across multiple IBM research labs in Elmden, Yorktown, Cambridge, Haifa, and Zurich. We have released our Granite Vision model about end of this February on Hugging Face, and the community response has been truly encouraging, actually. On Hugging Face, our Granite Vision model has received over 150K downloads, and the number is growing steadily. We have seen like a strong engagement on platforms like Olama. With Granite Vision 3.2 model, we are reaching 150K downloads, and over the IBM Watson X platform internally, we also have about 150K usage. And beyond these numbers, it's been exciting to see developers, researchers, and creators actually testing the model and sharing their experience. This kind of feedback helps us to improve the model and shows that Granite Vision is already useful in the real world application, actually.
Yeah.
And yeah, and to be honest, I also mentioned with Satya early this morning. I'm often amazed by what the model can do, especially when I see examples shared by the user or bloggers that we didn't even anticipate
Yeah.
during the model development. Yeah.
Right.
Let me just show you an example from Merv, which is a blogger. Actually, she actually used a real example from EU greenhouse gas infographic, right? And using Granite Vision for like chatting. Actually, for this infographic, you can see it's like a very visually dense and contains historical data, projection data, and some policy targets. And what is the user sent? The prompt is very simple. Explain the chart in detail. And you can see from here, the model responds with a very structured multi-part explanation, correctly identifying the time ranges, like where is the projection data, where is the historical data, and the emission trends, the policy goals, and even providing interpretations of the chart layout and messages. The user caught quite a high quality generation. And we think it reflects what makes Granite Vision especially strong, the ability to understand a complex, structured visual content, not just simple photos or captions. And how did we get there? Let's dive into the data. One of the key reasons Granite Vision performs so well on documented image-related tasks is because we have collected and curated a very comprehensive dataset for training, especially for documented images. And in total, we collect about 13 million images paired with 18 million instruction style QA pairs, covering a wide range of tasks and image types. As you see here from the chart, from the sunburst chart, the data includes like public data sets like docstruct4m and IBM curated real-world and synthetic data sets, and a mix of different image types like charts, diagrams, flowcharts, tables, infographics, and UI screens. And these slides give you a more complete look at the documented image dataset that we used in the training for Granite Vision. We have put together over 70 datasets covering a large variety of tasks like document image QA, chart and table QA, diagram reasoning, grounding, syntax recognition, UI screen, and document structure parsing. We are able to convert all of this dataset into a unified JSON format to streamline the pre-processing and the training. I mean, the data comes from a mix of academic benchmarks and the real-world corpora and synthetic data we created internally. This level of coverage helps ensure the model isn't just tuned to one domain, but can be generalized across a wide range of enterprise-relevant tasks. Yeah, in addition to that, we also use general image in our training, right? We also train Granite Vision on general image dataset to help it to handle a broader range of visual question answering tasks. This came from 3 major sources like Quadron, Lava Vision, Cambrian 7M. As shown in the breakdown on the right, we make sure to cover a mix of visual QA questions for general image, like general VQA, image captioning, math sense reasoning tasks, and also like more complex image comparison tasks. This dataset actually complement our document-centric data by building a strong generability, which is crucial when you want a model that work well in the real world and in enterprise settings.
Right. And so I have this little story about how this thing has progressed. Vision language models have progressed over the last few years. So my son is very good at math. In fact, he was selected for the top, there is International Math Olympiad where kids, high schoolers are selected. There are 6 high schoolers who are selected from the US. But before that, you have 60 high schoolers who are selected for something called MOP, Math Olympiad program. And they train people for Math Olympiad, and then 6 from that are selected. So this year, my son was in MOP, and it's a year-long process. It will take year-long to know whether he'll qualify for International Math Olympiad next year. But so he has this very, I've been challenging him for the last 2 years that, oh, give me a math problem, VLM, VLM will solve it. And it used to be so embarrassing that he would come up with a problem and it will give completely wrong results, right? And starting earlier this year, right, some of his very tough problems it was able to solve. And now this summer, I have employed him actually because we are also doing a VLM course later this year. So I wanted to understand, how good or bad it is in solving math problems. So all the easy problems it nails, right? Most of the VLMs, they will nail problems until, 12th grade or something. But math Olympiad problems, they are still not 100% there, right? They are struggling with that. And so we'll see, this year, I think two teams, right? DeepMind as well as they were able to get gold medals, but they were not able to beat the best human competitors, right? And so that is going to change next year. People are thinking that by next year, it will basically get a perfect score, right? So there will be other humans who get a perfect score as well, but AI will get a perfect score, which is very interesting. This progress has been from being very embarrassed by what results it was giving to being at a position where I cannot evaluate the answers because I'm not at that math level. Math level, I have to get my son to do it for me, right? It is it is very impressive.
Yeah, in some ways, we are like the children touching the stove to see if it's still hot.
Yeah. To be honest, it's a really fast-moving field. I think the advantage here for recent vision language model is benefit from the new development from the language model. Basically, when the language model containing more knowledge, typically the vision language model could perform better.
Yeah.
And I think that is why like a recent vision language models perform so well on like all different tasks, right? And what I also know, right, like as you mentioned, like maybe DeepMind actually almost already could win the medal for the Olympic Games. And we are very, I think for the field, it's very close. And I also know like some data company, like even here, PhD student at Harvard or MIT to do some Olympic math problems, step by step, with good reasoning and all the details, and fit that in the model. Right. And the model learns it. Right. That's amazing. Yeah.
The one thing I would say is, which my son and I we go back and forth because his whole point is that, oh, it's not good enough. He wants to show that AI is not good enough, and I'm the champion that, oh, it's going to get better. But the main thing he says right now is that, okay, it is impressive that it is able to solve it, but the answers are very computational. They are not using intuition, right? So you would have a geometry problem and it would solve it using calculus, right? It would get the right answer, but then nobody solves it like that, right? I mean, it is just a very bad way of solving it because humans won't do that crazy computation. So there is an intuition behind how to solve this geometry problem, and sometimes it misses that intuition and goes for brute force calculus kind of solution.
That's true. Let's see what will happen next. Who knows? Exactly. Maybe the large language model is doing so well on reasoning and thinking nowadays, right? Like, maybe that can be even fixed. I don't know. I will give it a shot actually in the next few months.
Exactly.
True. Yep. Okay, let me talk more about how we prepare the data. Actually, we have very comprehensive like data preparation pipeline. We place a very strong emphasis on data cleanliness, safety, and legal compliance. Here are a few steps like how we ensure the data is safe and legally sound. We perform like a face blurring to all the sensitive or personal image data to protect individual privacy, especially if dealing with public available photos. I mean, like as a general user, I probably do not want the model to know my name, right? We also perform like a license-based filtering keeping only like the content with a clear and a permissive license, like Apache2, MIT license. We also implement like a non-US data filtering, which required based on our legal or compliance boundaries. And crucially, we introduced a semi-automatic process for CSAM content detection and removal. Actually, CSAM stands for Child Sex Abuse Materials, to ensure our data set are free from any abusive or harmful content. I mean, this layer of
Super
filtering,
important. Super
yeah,
important.
super important. It's amazing to see like it's a lot of like data set collected from the internet could contain some like not safe for work or CSAM content, and we are working with the legal to make sure we are not only removing the data within any IBM machine. We also plan to contact with Hugging Face or where we get the data to make sure people can get clean data from online. Yeah, this is just as critical as the model architecture or training strategy, because like high quality or
Absolutely.
safe data makes a safe and reliable AI possible. Yeah.
And it's also unfortunately, right, this is also something that can be pushed under the rug because nobody is watching. You don't know what people use to train. So
Yes.
it's really good to see IBM taking good care to make sure that these things are removed.
Thank you.
Yeah.
Thank you. Yeah. With a great data in place, let's move to the model architecture. Actually, here is a very high level view of the Granite vision architecture. It follows the typical like a vision language alignment pipeline and consists of 3 key components. A vision encoder, right? In our case, we use SIGLEAP for strong visual grounding, and a vision language connector, which is a simple but effective 2-layer MLP, multi-layer perception, and a language model. In this case, we use Granite 3.1 2B language model with a 128K context length, which allows it to handle long documents and rich multi-turn conversations. And taking as an example of the image, right, and a question about the image, the pipeline we follow is to first feed the image through an image encoder. Then on top of that, we have a perception module, which will align the output embedding, the image embedding, with the input of the LLM. Then we can fine-tune the LLM to produce the desirable responses. I mean, this training strategy is very highly efficient. We do not need to pre-train the full LLM or image encoder from scratch. Instead, we align modalities through fine-tuning, which saves a significant amount of compute compared to training a full multi-model foundation model from scratch. And
can I ask a question? With this architecture, because you said that you're not training the large language model or the vision encoder from scratch, right? Does it mean that somebody who has a few GPUs, let's say 4 GPU machine, can they actually train the model, or is it too? It still takes a long time.
In our settings, actually, the language model we have is about 2B, and the total model size is about close to 3B, and we use about, if you use like 64 GPU, it could take 5 or 6 days.
Okay.
I haven't tried to use only 1 or 2, like very few GPUs, but I think if you work with 8 GPUs, actually it's doable. Yeah. And maybe you can try some like distilled language models even, right? Yeah. If you have a smaller language models, you can have a large model like a batch size and use less GPUs for the training.
Right.
Yeah,
and these are 64 H100s or what kind of GPUs?
Yeah, we're using H100 GPUs actually.
Okay. Yeah. Okay. All right. Yeah. So, but for practical purposes, most people, right, like 99.9% of the people would not need to train it from scratch, right? It is it is something that you may fine tune on your own data, and that definitely can be done starting with your model, right, the Granite
Yes.
vision model, even if you need to fine tune it, right, most of the time you don't even need to fine tune it because it's a foundation model. But even if you need to fine tune it, then a 4 GPU machine should be enough, right? Like a
Yes.
consumer.
Yes. Yeah.
Okay.
If you want to do something quicker, you can even do LoRa or
Yeah,
quantized
that's
LoRa, right? Which will be much faster. Yeah, and yeah, I do remember there are already some creators building notebooks or like blogs for how to LoRa or Granite Vision model. Yeah,
that's
I
very
can share
nice.
the link after the meeting, maybe. Yeah, yeah. And for ours, from our side, actually, we build up this training based on the Lava open framework to train our model, which is also open source, right? And but we indeed introduce several enhancements, like we use multi-layer visual features instead of just using the final layer as in the Lava standard repo. We adopt a dense grid resolution in the image patching, similar to any resolution, which helps the model to understand the visual content, which is essential for complex documents or chart or tables. And for the training, we also use multi-stage training process. First, we train the vision language projector to align the image encoder with the language model. And then we perform the instruction tuning on the curated instruction tuning dataset I just mentioned before. Yeah. Now let's take a look at how Granite Vision performs in practice. This table summarizes our evaluation results across a range of vision language benchmarks. We compare Granite Vision against both models in the same size range, around like 1 to 4 billion parameters, as well as larger models like GPT-4a or Gemini 1.5 Pro. In the small model categories, Granite Vision achieves leading scores on most key benchmarks like DocVQA, Chart QA, outperforming other models like Phi 3.5. Because this is the evaluation on this February, so we are comparing the Phi 3.5. And but I mean the performance is very outstanding. But perhaps like what is more impressive is that our performance approaches and in some cases matches like those much larger commercial models, right? If you go look at the Llama or Gemini or GPT-4a models, actually on some of the benchmark or 3B model match the
Wow.
performance.
Yeah, that's impressive. That's very impressive.
Yes.
Yeah, I'm looking at, for example, and the second one, you can see that Llama 3.2, that's a larger model, is
Yes.
at 0.85, and you guys are at 0.87, right?
Yes.
Very
Yes.
impressive. Very impressive.
Yes. Yeah, this results really speak to the strength of our data curation and the training strategy. It shows that you do not need a massive model to get a strong real-world performance, especially in document image understanding. Yeah. This strong performance highlights the model ability to understand layout, extract structured content, and reason over complex visual input. And it is worth emphasizing this is a very lightweight 3B model. It's fast, efficient, and deployable, while still delivering high accuracy across like all kinds of benchmarks. I mean, you can even run it on your own laptop, right, without the GPU. And I'm also excited to share that our recently released Granite Vision 3.3 2B model just achieved the top tier performance on the OCR bench leaderboard. As we know, the OCR bench is a comprehensive benchmark that tests model on multiple OCR related tasks like text recognition, syntax VQA, document oriented QA, key information extraction, handwritten expression recognition. Granite Vision 3.3 ranked number 2 in general, just behind a 7B model, and it is currently the best performing open model under 4 billion parameters. Especially like for strong score, the same-way QA, and key information extraction, showing that it can both read and reason over complex visual text structures, which is exactly what we target for enterprise document understanding. In addition to the performance, we also put significant effort in ensure that Granite Vision is safe and responsible to use, especially in enterprise environment. These slides show evaluations we conducted using two public safety benchmarks like a VRGuard and the RTVRM. Our model achieves the competitive or better results across key risk categories like unsafe content detection, misleading responses, etc. And then in the second table, we also show that by adding a lightweight safety vector mechanism at the inference time, we can significantly boost safety scores without retraining the base model. For example, on VRGuard, our accuracy improved from 86% to 96% just by introducing a small set of attention-based safety indicator. This result shows that Granite Vision balances the capability with responsibilities and can be tuned or extended for safer deployment in practical use cases. Yeah, to wrap up things before Q&A, I want to show a few concrete examples of how Granite Vision can be used in real-world settings. On the left, you can see a receipt, a typical document image, right, in our daily life. The model is able to extract the total order price with high precision, parse the ordered items in structure forms, right, what have been ordered. This showcases Granite Vision's ability to understand the layout, read text, and extract structured information, exactly the kind of task that's common in automation workflow for retail, finance, and operations. And on the right side, we have a very different use case. It's the same understanding for insurance or accident assessment. Given just the image, the model provides a detailed multi-sentence descriptions, noting everything from the damaged car to the high visibility vest and the template in the inspector's hand. This example highlights how Granite Vision can handle both structured document tasks and open-ended visual reasoning, all in a compact and a small model. It's very impressive, actually. Yeah.
That is impressive, very impressive.
Yeah, it can like read. This is like a general image, right? It can understand the thing and even know, oh, this is a car accident. Who is the parent is and whose responsibility it is. It's very amazing. Yeah. Here is another competing example that show Granite Vision's ability to handle like a highly structured real-world forms, something that's common across legal, financial, and government use case, and even like in our tax season, right? This is some like a national service interest actual form, and it contains handwritten entries, tapped fields, and very dense legal content. The model is asked to summarize the document at a high level, identify the member who is filling this form, and even check for like missing signature fields, right? Granite Vision is able to extract all this accurately, identify the name on the form, and confirming that a borrower's signature is missing. This shows that the model can like read both tabbed and handwritten content, understanding the field's semantics, and also perform context-aware checks across the document. This is very amazing. Yeah, these capabilities are like essential for tasks like a document automation or loan process or like a legal review, where correctness and detail matters. So what's next for Granite Vision? Yeah, honest, I'm very passionate about build the best large vision models actually, because as someone closely involved in building these models, I'm consistently amazed by what they can do, right? And yet we know there's much more room to grow. And we are actively pushing the boundaries to develop the next generation of large vision language models with several exciting directions in the progress. Like we really want to build the hybrid architecture with a mixture of expert. We are building the models that can selectively and active different expert pathways based on the input image or tasks, improving both performance and efficiency. And we also want to aim to enable multiple vision encoders for the large vision language models, allowing the model to handle diverse image types more flexibly, from nature photos to like very dense document and charts. We also aim to enable the vision language action ability beyond just describing the image. We want the model to reason and act, especially in the interactive and multi-step settings. And finally, the Granite Vision models are already integrated into Docklink, which is an open source document processing and parsing tool developed by IBM Research as well. With this pipeline, you can process any kinds of raw documents in any format, extract the element like figures, charts, and then interact with Granite Vision directly. Yeah, let's wrap up my talk. Thank you so much for your attention. If you'd like to dive deeper, please feel free to check our paper at archive using the link here. You can also find the model and documentations through the QR code below. We are on Hugging Face, GitHub, and IBM.com for sure. Now, I'm happy to take any questions.
All right, fantastic. Thanks so much for that. So I think we will take this time now to do our trivia giveaway before we do Q&A. Let me go ahead and bring back Dr. Malik's camera here. Hey there. So, hey folks, if you are joining us for the first time, or if you just need a little reminder, one of the things that we do on this here program is a giveaway to you out there watching of a free OpenCV University course of your choosing if you win. You can see what courses are on offer by going to OpenCV University. That's opencv.org/university. You can also just scan this QR code that I put on the screen if you're watching right now to see what courses are on offer. And if you don't win, maybe get yourself an OpenCV University course anyway. Transform your career with courses on computer vision, deep learning, and the state-of-the-art artificial intelligence stuff that we talk about here on the show every single week. Before we do that giveaway, however, I'm going to remind you that OpenCV Live is brought to you by OpenCV University and the sponsors of OpenCV. I'm going to maximize this window here. Thanks so much to OpenCV's members and partners. The current ones are listed on the screen here. We do really appreciate their contributions. OpenCV is a nonprofit organization in the U.S., and if your company makes use of OpenCV, one of the ways that you can help keep open source computer vision alive is by becoming a member. You can just send an email to me. That's phil@opencv.org, or you can go to opencv.org/support to find the various ways and membership programs that you can make use of here. OpenCV, this episode is brought to you by OpenCVU. As I said, currently an exclusive 35% offer on all OpenCV University programs and courses for just another day and a half or so. You can go to opencv.org/university to make use of this incredible offer. And like I said, even if you don't win our trivia giveaway today, 35% off is nothing to sneeze at, celebrating 25 years of OpenCV with a 35% offer. Today's episode is also brought to you by RoboFlow. Everything you need to build and deploy computer vision applications. You can try out RoboFlow for yourself absolutely free by going to roboflow.com/OpenCV. That's roboflow.com/OpenCV, making some of the best tools for computer vision for developers and the enterprise. One of my favorite things about RoboFlow is RoboFlow Universe. A huge creation here. The world's largest collection of open source computer vision data sets and APIs, over 250,000 fine-tuned models, 1 million data sets for free. That's universe.roboflow.com. You can check out some of the ones they've got here, such as rock, paper, scissors, license plate recognition, people detection, some of the simple ones. There's also, importantly, the RoboFlow 100 VL, the first object detection benchmark for vision language models. Pursuant to our conversation here today, you can go check that out at universe.roboflow.com. RoboFlow has been an OpenCV member for several years now, and we really appreciate their support. Thanks so much to our sponsors and all of that good stuff. Now, on with the trivia giveaway. If you've won in the last few months, please do not answer and give someone else a chance to win. This one is going to be a two-parter. So you have to answer both parts of the trivia in the chat at the same time, not in two messages, one message, both parts. This goes for Zoom. This goes for all of our viewers everywhere. YouTube, LinkedIn, etc. I'm watching in the chat. I will reward the fastest draw, as they say. So today we've been talking about the Granite Vision models. They come in a couple of different sizes. What are the largest and smallest models in the Granite Vision family currently in terms of billions of parameters? What are the largest and smallest? Let's see if I got them this week, you guys. They were super fast last week. I was pretty mad about it. Oh. They answered before I was done. So let's see if we can see what we can get. You're close there, Venkatesh, over on YouTube. Now it's we keep in mind we're talking about the ones that we talked about here on the show. So you should be able to find the answer here on Hugging Face. What are the highest and lowest that we talked about here today?
Yeah, actually, for the Granite Vision, we only have
let's
one
see.
model
Hang
size.
on. Let's see here. Oh, we got it. I think we got it on Zoom. The ones available on Hugging Face. The answer we were looking for here, in terms of parameters, 2 billion and 8 billion. 2.5, I think, technically, but I'll take it. Carlos Mendez over on Zoom finally got the answer. I got you guys. This is the first time in probably like 3 or 4 months that it took more than 30 seconds for the audience to answer today's trivia question. So I'm going to celebrate with a sip of my coffee. That's good. All right. Congratulations, Carlos. Please send exactly one email to me. That's phil@opencv.org. After you go to OpenCV University, opencv.org/university, and check out the courses are available. Pick the course you want. You can also scan the QR code I just put on the screen. Pick the course you want. Send an email to me with the name of it, and we will make sure that gets unlocked in your account. So we've got quite a few questions here today. Let me go back here and dig around. So there's a few on Zoom, which I'll take me a second. I'm going to paste on the screen here, but first I'll pull up. Here's one here from Nashad. I'm going to go ahead and drop myself off here since I won't be answering these questions. Are the weights available online for Granite Vision?
Yes, the whole model actually is open source. You can feel free to download the model on Hugging Face, right? Yeah, it's all open. And under Apache 2 license, basically give you not academic usage, you can even use it for commercial usage as well.
That's
Yeah,
awesome.
and it's the same license we use at OpenCV as well, Apache 2.
Yeah, we love open source.
We've also got Jason saying here on YouTube, is the Granite VLM possible to be fine-tuned locally? We talked a little bit about that, I think, toward the end of the presentation. You said something about like it will take a few days with a single 5090, I think you said. Was that the case?
Yeah, it depends on how you want to fine-tune, right? If you want to directly fine-tune the whole model, I think it will cost a little bit because it's still a large vision language model, like with close to 3 billion parameter size. But if you want to do LoRa or cuLoRa, actually you can even find the notebook on our Hugging Face page. We provide the notebook for cuLoRa fine-tuning, and you can fine-tune on your own workstation. Yeah.
That's awesome. Yeah, and the size of the model is such that a 4090 would fit easily.
Yes.
Right?
Yes.
Yeah, that's one of the things that's I find that's just that surprised me with regards to the benchmark results and stuff. It's a pretty small. It's a small enough model that you can mess with it locally, pretty without spending $2,000 on a GPU. Maybe $500-600, right? Like you'll be pretty good.
Yes.
Yes. So let me bring a couple more questions here. So over on Zoom, we've got
actually,
go ahead.
I have while you're selecting the question, I have one other question. What are the use cases when somebody would need to fine tune a model like as powerful as this one, right? Is it like on your specific data, it's not giving good accuracy, or is it there are other cases where you think that fine tuning would be required?
Yeah, what I learned now is like actually all this vision language model performs very well, even without fine tuning, right? But once a customer or user comes in and brings their own data and it's very specialized data, you may need to do the fine tune. But to be honest, as I mentioned, the model performance always amazed me. During the CVPR demo, one user comes in and saying, "Oh, does this model work with the CAD image?" I have no idea, right? Because there's no benchmark for the CAD image understanding or VQA. And the user just download image from just Google search and download it on the laptop and give it a try for the Granite vision model. And ask the model to describe the parameters of each part in the CAD image, right? It's a 3D drawing for calendar or something very complex, like mechanical engineering, maybe image. And the model works amazingly well. And I have no idea, to be honest. And actually, I don't think there is actual like a well curated CAD image data in our training data, but the model learns the ability, right? So basically, I mean, like even without fine tuning, I feel the model work with many use cases. But if you have a very specialized use case, I mean, like you can do the LoRa or cuLoRa, like quickly fine tune and test.
Yeah, and so one obvious one that comes to mind, where let's say I start a hat company, right? and my hats are not named as regular one, right? Let's say this hat, I call it some very specific name,
the Satya.
right? Let me call it, the Satya hat, right? And obviously there is no way for the model to know that this hat, we have decided to call it the Satya hat, right? Then fine-tuning will be very useful, right? On your own catalog of names.
Absolutely.
So that's what we have seen in our consulting services also, right? I run a consulting service in computer vision and AI, and there most of the time, out of the box, the vision language models are working very well. But when there is a specific requirement, right, the name is not, the company just cooked up a name, right? It's their brand name, and it's not public information, especially with products which have not been released, right? That is not in public domain yet. then you need to do that kind of fine tuning. And the company also wants that, okay, they cannot mess up. These names should be accurately represented, then fine tuning is required.
Yeah, the branding guys get real mad about this stuff. And ask me how I know. Ask me how I know. We've got a few more questions here and a little bit of time left. So let's back over on Zoom. Someone asks, I believe this was Percy asked. Percy, I'm not sure how to pronounce their name, but thanks for the question. What would be the minimum sample size for fine tuning?
I feel if you want to just do the LoRa fine tuning, maybe 20K or 40K could be enough, right? For some simple tasks. Yeah, that's my estimation. Yeah.
Okay.
And what does it entail? What kind of data do you need? Is it image and caption pairs? What does fine tuning entail? What kind of data?
Yeah, actually, the image caption pairs absolutely should work. But I think now, like especially nowadays, people trying to use very high quality instruction tuning data, basically with image and the QA pairs. And also for the QA pair, it could be like a reasoning and a multi-turn QAs. Right, like the math solving problem, right? You could have like, how to solve this issue given this picture, and the answer should be like, the first step, second step, and if the another turn could be, can you go deeper? Can you fix this or that? Yeah, this kind of instruction tuning data set.
So instruction training and not just caption data.
Yeah,
okay, that's very interesting.
Yeah. All right, that makes sense to me. Not a question, more of a comment, but Himgogo, I'm not sure if I got the name right there. I'm gradually loving the idea of becoming a computer vision engineer. So much can be achieved with computer vision. You're right. It's true. And you can achieve many things with computer vision, especially if you take an OpenCV University course at opencv.org/university.
Totally agree.
Yeah, and also if you look at the hires, there's a war going on in the industry right now, and people are poaching. Facebook is poaching from Meta is poaching from other companies. There's a war going on for technical talent. And if you look at the people's backgrounds, a lot of those people are computer vision people, right? So very, very interesting.
Yeah. Absolutely. If you think about where the neural network comes from, right? It comes from CNN and all the CV domain. Yeah.
So I feel that large language models they were the low hanging fruit in some sense, that because the text data was widely available on the internet, so that was the first step. But then you hit a limit because all the data has been consumed, right? Most of the data has been consumed, and now it has to go to video and image data and also speech data. So, and also in general, right? If you look at whenever AI interacts with the real world, it is the vision sensor that comes into place. Tesla full self-driving, that is a computer vision solution. Medical diagnostics, that is all vision based, right? If you look at AR, VR, there is a lot of vision in it. Like Apple Vision Pro, if you think about it, it is Apple Vision Pro. It is a computer vision device because there are cameras looking outside trying to locate your head in the scene, and there are cameras looking inside trying to locate your eyes also. So yeah, I think computer vision, it is the next wave of AI that is coming. It is going to be deeply rooted in computer vision.
Yeah, I totally agree. Like especially I have a bit like a data science background, right? And as I totally agree, like for the language model, we collect a lot, like all the text data from internet or whatever. We have very comprehensive, like a multi-text text data. But for the vision language data, actually, we do not have full coverage, even though there are some very popular public data set available. But still, if you look at the specific topics like image types or task types, we are still lacking a lot of data to just build the best vision language model. That is why I'm thinking we are just start. Yeah, we have much more room to improve.
Yeah, everything old is new again. Everything right is wrong again, as they might be giants would say. We've got a couple more questions here from, I've got one more over on LinkedIn from Smotty who asks, can I use Granite Vision with medical imaging papers?
Oh, yeah, absolutely. Yeah. But for what? I mean, like.
Yeah. Do you have any examples that you could come up with?
Yeah, maybe you can like use the Granite Vision model maybe for the like a document summarization or explain certain charts or figures showing the document images, like have a description or have a chat with the figure showing in the document page, right? Oh, what's the maximum number for certain columns, or what's this symbol or certain drawing meaning in the figure. Yeah, but actually medical imaging like is a very broad domain as long as I know.
Yeah.
Yeah,
that
hopefully
makes
I
sense.
answered your question.
There is another MedGemma is also nice. People can look at it. MedGemma. That is also trained specifically on medical data. So that's something people can look at. And also you'd be, I mean, when you're working cross-domain, right? So a lot of times we solve computer vision problems that are not, we don't have any idea, right? Even simple things like if you're working in dental X-ray analysis, there are so many different conditions that we have no idea, right? In fact, we cannot even, if you give us a picture of a tooth, we don't know which tooth it is, right? I mean, so
You're
those kinds
offending
of,
all the dentists out there. There's got to be a few.
No. We, as in, I'm saying people who are from a computer vision background, but not from a medical background. Of course, the dentist, they will know, oh, this is the upper blah, blah, blah molar, right? So they know it very well, but we don't know. But we have to work with that kind of data. And it becomes very useful when we are able to upload a picture or a chart or something, and then question answer, and then you finally figure out, right?
Totally agree.
But the process is, because those could be terms, that could be acronyms, etc., that we don't know. But once you interact with a vision language model and in a question answer format, it can make your learning so fast compared to, let's say, Google search, right? It's very difficult to do Google searches on these images.
Yeah, especially these days, partly because of AI slop. But let's a couple more questions here. We got a good one from Zoom. Is English the only supported language in the documents, or does it work with other other languages?
Yeah, actually, for the training data set we use English QA pairs. So we theoretically, the Granite Vision should only support the English language, but I believe actually some of the let's say image content, maybe Chinese or other characters, and also the large language model we use also support multiple languages. So surprisingly, the Granite Vision model actually support multiple languages. Yes.
Yeah, that's
very
funny how that
interesting.
happens.
Yeah, even without like enough like training data from other language, right? It still works well.
Yeah.
That is funny how that works. We got one more question here from Zoom. This one's kind of in depth. It says, how does Granite Vision model perform compared to NVIDIA Nemotron Nano 8 billion VLM? Does this work on handwritten documents, or should we fine tune it? Also, does it need an NVIDIA H100 for inferencing? A threefer of a question here from Zoom.
Yeah, actually, I'm not very familiar with this model, but we indeed compared with NVIDIA's NVRM 72 billion model. I think the performance is very close, and we also tried some examples showing in the NVRM paper, like the math problem one. Actually, the Granite Vision works perfectly well. And regarding for the handwriting documents, like understanding, I think we are the state of art. So basically, you do not to do the fine tuning. I guess for the document image understanding. So yeah, for the inference, for the inference, I don't think you need the H100 for inference. As I mentioned, like it's a very small 3D model. It can even work on your laptop, right? Yeah.
Yeah, GPU would be good so
Absolutely.
that you get a response quickly. But for inference, you should not need standard GPU will
Yes.
work. Gaming GPU
Yes.
will work.
And for handwritten documents, it works well for this, or does it? Okay.
Yes, it works pretty good,
State of
and
the art.
especially we are now like the second on the OCR leaderboard, right? Which is like a very
Yeah.
comprehensive like a benchmark for this kind of OCR or handwriting recognition tasks. We are very confident that like we are the state of the art.
Fantastic. Yeah. So now,
So,
go ahead, Satya.
one last question. So these models, do they, obviously IBM Research is working on these models. Do the same models, they become part of IBM products as well? How does it work? Like, or is it a different model? The open source model is preliminary, and then there is more that goes into the final model. How does it work in
Yeah.
IBM?
Yeah, for that part, I'm not 100% sure, but from our side at IBM Research, we dedicated to publish open source model, publish the state-of-the-art model that we have, right? And
Right.
but if a client come in with IBM sales, we may need to like find a solution for them. I think that's the way how
Got
we
it.
handling
Got
the client. Yeah, yeah, but
Right. But it would be based on the models that you're developing. That is the my main question was that is the model being like, are you doing dog fooding of the model, right? That you're using the same model that you're
yeah,
publishing.
we are using the same model. Like we publish on Hugging Face. We are very dedicated to the open source. Actually, yes.
Perfect.
Thank you.
Nice.
Yeah, we appreciate that. So now is time for the most important and best part of the show. Pets wearing OpenCV merchandise. So if you have a pet and you send us a picture, I'm gonna open it up, even if your dog or cat or hamster or whatever is not wearing OpenCV merchandise. I will probably put them up on screen. We've got an update. So last week I talked about how our little homie Violetta was not feeling well with a tummy ache. I'm gonna go ahead and upload. Let me put Violetta. There she is. Hola, Violetta. One of our earliest purchasers of the OpenCV scarf. You can get your own OpenCV merch by going to the official OpenCV shop. You can scan the QR code there, or you can go to opencv.myspreadshop.com. Violetta is fully recovered and is back to barking at the doves outside her window and devouring, I'm told, chicken as she loves to do. So thanks and welcome back, Violetta. We're glad that you're doing okay. You can have your beautiful pet on screen as well here on OpenCV Live by sending an email to me. That's phil@opencv.org with the photo attached and your pet's name. And we will say hi at the end of the show because, we talk about a lot of serious stuff here on the show, and it, we like to, a spoonful of sugar helps the medicine go down, as they say. So congratulations on your recovery, Violetta.
Right. Very nice.
Yes, I'm going to, Doc, you want to go ahead and take us home? I think we're ready.
Yeah, thank you so much, Penguin. So for this presentation, this was amazing. We learned about a new vision language model, and it is state of the art in many dimensions. So we wish your team all the best, and we are going to try out Granite Vision model ourselves. Thank you, our audience, for being here every week. It is a pleasure to serve you and to bring you this amazing content, right, from amazing people. And thank you, lastly, Phil, for putting up the show. Nothing went wrong, and I'm really loving this new
Yeah, me
format.
too. It's pretty sweet.
It's growing on me even more.
Yeah, we can just have
Yeah.
Violetta on the show all the time now. We should do that.
Cool.
But yes. So yes, thanks so much for joining us this week. We learned a lot. I'm going to go ahead and maximize myself here and say, yes, take care of yourselves out there, folks. It is a tough world. I'd like to wish happy trails to the late, great Chicago Cubs second baseman Ryan Sandberg. Rest in peace, Rhino. I grew up a Cubs fan. He was my favorite player as a kid, and he passed away at the age of 65 this year. So the city of Chicago mourns the other great player in Chicago to wear the 23. R.I.P. Rhino. Let's get some runs for Rhino Cubbies. They're leading in the NL wild card right now, and my San Francisco Giants have really, really shit the bed. But take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. We will catch you next time. Same bat time, same bat channel, Thursday at 9 a.m. Adios.
Thank you, guys.
Thank you.